With the advanced built-in sheet metal capabilities of SolidWorks 3D CAD software, you can create complex sheet metal designs in a fast and intuitive manner. SolidWorks provides process-specific tools for designing sheet metal parts in both folded and flat state with advanced tools and functions. So you have the ability to produce production-level detailed drawings quickly. We are going to design a cover for this satellite receiver by working in the assembly. In this way, we can make sure the cover will fit over the chassis of the receiver. Let's start by sketching the basic shape of the cover and use the chassis of the receiver as a reference while sketching. Since our cover is going to be symmetrical, we only need to create half of the part, and then we can mirror the other side to save time. Our design intent is to have a 1 mm clearance from the chassis, so we can capture that design intent by dimensioning the cover in relation to the chassis. We are now ready to create the base feature for the cover. We'll activate the SolidWorks sheet metal tools to create a base flange. We can extrude the flange up to a point located on the chassis. Although SolidWorks provides several choices for sheet metal thickness, in this example we will use a gauge table to select our thickness. Our next step is to create a miter flange along the front of the receiver that will follow the existing lip on the chassis. SolidWorks provides a preview of the resulting miter flange, which helps us in choosing the correct side to add thickness. Because SolidWorks automatically detects when continuous edges are available, you can simply select them all. You can also easily offset the start or end of this flange, and SolidWorks will create the flange, automatically adding the gap required at the corners. To finish off this side of the cover, we will create an edge flange on the two edges. Notice that SolidWorks detected that the flanges would overlap each other and automatically adjusted the flanges. Let's flip to the other side of the receiver. At this point, we are ready to create the other half of the cover. SolidWorks provides a powerful mirroring capability that saves design time and ensures part symmetry. To create an interlocking flange between the cover and the chassis, we will now create an edge flange. However, we only want a portion of this edge. SolidWorks allows you to edit the sketch as you go by dragging the edges of the sketch and adding the relations you desire. We also want to use the outline of the existing hole in the chassis in our sketch. Since we have the complete set of sketch tools available, we can simply reuse the edge of the hole for our sketch, thereby automatically creating a hole in the flange. If we leave the flange as is, it will be on the outside of the chassis. However, our design requires the flange to be on the inside. Again, this is easy to do. Simply select the offset option for the flange position, and then specify exactly where you want the flange located. SolidWorks also automatically adds relief cutouts for you to complete the flange. At any time, you can work with the part in its own window without the rest of the assembly. SolidWorks comes with a library of sheet metal specific features, easily accessible from the design library. Here, we'll drag and drop an indent feature, which can be used for a finger grip, onto the side of the cover. You can easily locate the feature as needed. Another time-saving tool is the hem feature. We will add a hem to the back edge of our cover to finish it off smoothly. We need a finger indent on the other side of the cover, so let's mirror the finger indent by selecting the feature and the plane to mirror about. Remember that in SolidWorks, you can either select objects first and then select an action, or you can select the action first and then select the object. You decide which way you want to work. Vents are commonly found in many sheet metal electronics enclosures, and often are made up of hundreds of holes. With SolidWorks, the fill pattern option allows you to easily create the vents. Select the face where you want the vent to be located, and then select the style. Set the spacing and stagger angle, the margin, and the direction. You can use either the predefined hole shapes, as we are doing here, or you can create your own. It is easy to remove holes from the pattern. Simply select the holes to be removed. Let's see how our sheet metal flat pattern is developing. You can see the flat pattern by just selecting the flat pattern function. SolidWorks automatically creates the flat pattern from the 3D model, saving you hours of tedious work. Returning to the assembly, you can add the plastic front bezel for the satellite receiver, so you can check the fit on the chassis and cover. With SolidWorks, you can create 2D drawings at any point in the design process. Here, we open the part and create a drawing from the part, automatically adding the flat pattern view and the edge view. SolidWorks automatically adds all the required sheet metal bend lines. You can set up SolidWorks to color code all the sheet metal elements required, thereby enabling seamless transfer to CNC machines via DXF. At this point in the design, we get a call from marketing stating that they need to send some images of the receiver design to the customer. Can we add the screen printing art to the model? Not a problem with SolidWorks. Let's pop back to our assembly. Using our state-of-the-art decal tool, we simply select the art file from the graphics department, select the face on the model to map it to, and we are done. The innovative SolidWorks Advanced Sheet Metal environment, its wealth of tools, and its ease of use help make SolidWorks the industry leader in 3D CAD software.